It was about 2:45 in the afternoon, March 11th, 2011, and deep below the North American plate in the island of Honshu in northern part of Honshu in Japan, there was some stress building up. Now, you can think about it as the stress of stretching something that's elastic like this elastic band. And as the Pacific plate was being subducted below the North American plate, there was stress building up. And the next thing that happened, of course, was, I hope I get this to go. Boom. It just broke. I reached its elastic limit, and that's when there was a rupture, and that rubber band broke into pieces. And in the case in northern Honshu, Japan, it's when one plate was being subducted below. There, let me do it right here. This is the Pacific plate out here. This is Japan here. And one plate was being subducted below the other. And there was building up pressure right there. And all of a sudden, it shunted the upper plate, the North American plate, over the top of the Pacific plate. And it released an enormous amount of energy. When that occurred, a rupture occurred, and it was a huge earthquake. And so the earthquake was about roughly a 9.0. Now, that's one of the largest ever recorded. It's one of the three largest in the last 100 years that we know of, anyway, or four largest in the last 400 years here. 16,000 people died as a result of that event. 2,000 went missing. So roughly almost 20,000 people lost their lives to that event. And the worst part of it was when that plate broke, essentially, there was some slip. And when that slip occurred, when it released that tension and everything, there was a huge pile of water over the plate that was displaced. And when that pile of water collapsed and came back down, it generated a wave. And it was the tsunami associated with that earthquake that killed the most people. That was in the Tohoku area of Japan. And so 16,000 people lost their lives over that day and the next few coming days here. And it doesn't kill you immediately, you know. A lot of people drowned. A lot of people were beaten to death by the debris that was in the tsunami. A lot of people lost their lives in vehicles because they were driving along in the afternoon streets of many of the towns and villages that were along the coastline here. And if you're familiar with Japan at all, you know that it's a very hilly island. And so hilly and rivers means that it carves deep valleys. Well, these deep valleys kind of funneled that wave energy. And so you can see that actually in this image right here. It was a triple disaster in many ways, in fact. So nobody's actually, as far as I know anyway, has lost their lives to the nuclear disaster. But that was the last one. When the tsunami came in, it hit the Fukushima nuclear power plant. And so that tsunami overtopped the reactors. They'd been designed to withstand, I think it was 11-foot wall or so of water. And as it turned out, it was about a 20-foot wall of water. And so salt water came into the reactors and caused a nuclear meltdown, essentially. And radiation was lost to the atmosphere from that as well. It's a triple disaster. And so very commonly, earthquakes can lead to at least double disasters. Mass wasting events can do the same thing because earthquakes can generate mass wasting events as well, where hillsides will slide down and coming into villages and places like that. So this is part of the hazards of geology. We live in a precarious place on this planet. There's always things that are happening, and we live on a restless outer part of this planet. And so there are always going to be events that affect humanity. And so that's what we're going to explore today. In fact, I've broken this into parts. There are actually two parts to the earthquake disasters we're going to talk about first, and then we're going to talk about the actual processes associated with earthquakes. And so we get to do that in another set of events, okay, another set of presentations. So for the first two, we're going to talk about the disasters. So the first one will be for this week, and the second one will be the first one that you'll have for next week. And so you know more about plate tectonics than you ever wanted to know, probably, from the last two previous presentations. So here we go on what happens when you have earthquakes and plate tectonics and what happens. So that is a photograph here of, you can see the bridges were still surviving in some of these cases, but the town itself was pretty much wiped out. Many of these had seawalls that extended up the streams, and if you have an opportunity, and I don't really want to grab video from this disaster to show you, I would encourage you, however, if you just look up the 2011 tsunami, you'll see footage of this. And I'm not here to promote that, but it'll take your breath away. It's a very devastating sort of event that occurred here in northern part of Japan. And so we're gonna look at some more disasters then. I want to show you some images from this disaster as well, things that will surprise you perhaps. In this image, you can see houses that are floating. So these are ones that have come off of their foundation and they're floating out amongst the debris, in fact. So this would be after the event itself, after the tsunami came in. And I think it took like 15 minutes. It depends on where you're at along the coastline, but 15 minutes after the earthquake, then came this enormous wave. And it's not just a wave, I guess is what I would say. So the tsunami that came in was a wall of water that just wouldn't stop. It just kept flowing. It's not like a big curl that comes in. In fact, it's a wall of rushing and high water, essentially, that floods into the coastline. And then eventually, on a slow trajectory, it'll move back out to sea. And of course, it carries everything with it out to sea, a lot of things out to sea as well. Here you can see boats intermixed with the houses. You can see that there's fires in here as well. Those fires are from cooking gas and propane and tanks like that would have become detached and caught on fire as well from this sort of event. In this image, you can see here's a boat. They've cleared a pathway for people to come look for their possessions and their lost family members. And so you can see, you get an idea of how much debris there is with each one of these events. Now, this is not the largest tsunami on record, obviously. There were 250,000 people killed in the Banda Aceh earthquake and tsunami that occurred in 2005. And so this is the sort of thing that happens in tsunamis. And so it mixes the oceans and land, of course. And here's where it occurred. That's the Tohoku in Sendai province. They call it the Tohoku Earthquake. Sendai is the province in northern Japan here along the eastern coastline. The actual location of the epicenter for that earthquake you can see indicated by a red star right here. But the earthquake itself was down below that spot. And so that's where let me get it right here, where the Pacific plate was actually going underneath of the North American plate there. That's actually part of North America. And as it was descending, it stuck and then released and ruptured. And that's what generated the tsunami. But it's down here that the earthquake would have occurred, not there at on the seafloor surface up above that. That's going to seem to be where it occurred, but that's what we call the epicenter. The actual place where it occurred is what we call the focus. And so the focus would have been deep inside of the earth, but not all that deep in this case, just the thickness of that upper slab here. Earthquakes always occur along faults. Earthquakes almost always occur along faults. Seismic events can occur from impacts and things like that, but earthquakes almost always, the ones that are generated right here on Earth, happen along faults. So that's just a couple of definitions to give to you. I need to give you some background information before we get into what happens in these disasters. And you recall from the very first lecture in here that E equals mc squared. Energy is equal to mass times the speed of light squared. And so much of Earth, if it's not matter, is energy, of course, and so energy is transmitted from one place to another. So when that fault failed in that one location there on the plate at the focus where that rupture occurred spontaneously, and it broke the bond between those two plates, get generated energy, and that energy then gets transmitted through not only the plates themselves, it sends energy out around the entire world. And so, except for the P zone and the S, zone, shadow zones, but in fact, that energy gets dispersed. And so the Earth is like ringing a bell in many ways. And so that's it reached its elastic limit and it failed. And it's what we call brittle failure. It's where the rocks that are in the upper part of the lithosphere are still behaving, either if you can bend things, like I can bend my glasses frame here, right? And notice when I bend that, it pops back to its original shape. And that's what we call elastic behavior. And that's generally the way that the Earth would work in the outer part, except when you reach that elastic limit, things will actually rupture then. And so they transmit this energy in the form of waves. Now, the type of waves that you get from an earthquake, there are 4 types of waves, 4 types. P waves, you already know about. Primary waves, they're compressional waves. They're like sound waves, in fact. S waves travel side to side, however, and so as the S wave gets generated, it goes at a slower rate because it's taking the steering wheel and going from side to side the whole way, whereas the P wave goes in one pulse, essentially. So you get a compression, then you get the rarefaction, then you get the compression, the rarefaction, and that gets transmitted. It's transmitting energy. And so the next type of wave is actually just at the surface. And so these are the ones that oftentimes will knock down buildings. Surface waves have the tendency to be like a pebble in a pond, right? So you pitch the pebble in a pond and you get these surface waves that get generated at the top of the water there. And so they go up and down. There's another type of surface wave. Those were called Rayleigh waves, by the way. So Rayleigh is the person who discovered that sort of phenomena, up and down. And then there are love waves, which go from side to side in the same sense that it's like an S wave at the surface, right? So love waves are the other variety of earthquake waves that are generated. So there's 4 types: P waves, S waves, and surface waves, which can be divided into Rayleigh and love waves. And so 4 types of waves that we get with earthquakes. So when we record these, we record them on what we call a seismic station or a seismometer. And the instrument itself is called the seismometer, or a seismograph is the other term that we sometimes use for a seismic station. And the recording, the actual paper recording or the digital recording of that event is called a seismogram. It's like a telegraph sends a telegram, a seismograph records a seismogram. And so the seismogram is shown in this situation. That is the Tohoku earthquake. And that was a magnitude 9, enormously powerful earthquake. And what you see here is a series of lines across that record that show no movement hardly at the upper part up here. So it goes black, red, blue, green, black, red, blue, green, and 15 minutes in between each one of those lines. And so it's doing it by time. And so it goes 15 minutes, nothing. 15 minutes, nothing. That's the blue, the blue line is next, 15 minutes, nothing. And you keep going down through the record. And eventually you finally get to the point, and you can actually see on here where there's a blue line that goes all the way across, and then boom, something happens. And so the needle then begins to move. And so it begins to record that earthquake then. And it will record different colors with each one of those 15. So this was ringing for a long period of time. Now, this was actually recorded in the Aleutian Islands, not all that far away from Japan. And so that is the record of a pretty close seismometer that's recording that earthquake. And so you can see that's what a magnitude 9 looks like. After the main shock was finished, you can actually see the waves that developed. And so that's the ringing of this bell. And you can see these sort of long amplitude waves that last 2 or 3 minutes, some of them. And so you get this sort of like up and down. Well, that's what they generate, up and down motion, but they also record this energy traveling very, very rapidly, about the speed of sound, actually. And so the event keeps going, and you can see it sort of finally settle out towards the bottom of the seismogram here. So what was happening, and what that's recording, in fact, is stress that's along a fault. The fault breaks, it reaches its elastic limit, and then things move. And so that's kind of what it shows you on the left-hand side of this diagram. Now that's more like a California-style earthquake here. Again, very shallow, however, but in California, there's a strike-slip fault there that's moving. It's the San Andreas Fault. It's the largest fault zone there, and it moves from side to side like this. And so it builds up pressure with the two plates impinging on each other, and then eventually, boom, it jumps and breaks, and you have that rupture. And that's what it's going to generate the energy then. I'll show you just a few more of these now. So if the seismograph or seismometer measures that energy, it's the seismogram that records it. This is another recording from China Lake in California. So this is almost halfway around the world. And you can follow how the lines were tracing across with little tiny minor seismic events. Now those could actually be like a truck driving outside of the station. So what they try to do with these sort of devices is to isolate them in a way. And so what they're recording is just the motion of the Earth itself. I have a story to go along with this, actually. You can think about a seismometer as a recording device, right? My former department head and his wife had actually experienced an earthquake when she was a child. She was playing the piano. She says, I remember I was sitting at the piano, and then all of a sudden, she was sitting on one of these piano benches, and she began to move, she says. It's like, and the whole thing is like it was shooting me all across the room. It's like, well, technically, you were remaining stationary because you were on those wheels. And it was the room around you that was moving. And so she was actually a stationary device. And that's what these seismometers rely on. They stay stationary, but they record the movement around them. And so this is one of those places where they do that. And so one of the 5 largest recorded, of course, at a 9.0. And so here's the same record again. And some of you guys may be familiar with this. Sometimes when you reach the limit of what the pen will draw, it'll actually, oh gosh, what do they call it when it does that? But it pegs it out, right? And so you can't actually get the entire amplitude of that energy. And so you can see the red spots on this seismogram here from the South Island of New Zealand. Now this is closer than China Lake, I think, slightly closer than China Lake, and so it actually truncates the top and the bottom of the needle swing in this case. And so there's a pen, or a digital pen in this case, measuring that response. And so you can actually see on here the up and down motion of the earthquake here. And so that is how they hit. So the P wave would arrive first, and then the S wave after that, and then eventually the surface waves will come in and affect the seismometer as well. And so you can see also on here the aftershocks, and that's why I put this on here, so you can see the aftershocks that are also pegging out the needle on this as well. So huge earthquake this thing was. So from New Zealand we record it. In other places around the world it's recorded as well. This is in Tennessee. And here you can nicely see the amplitude. And we can try to spot where it actually begins to deviate. I think it's along the red line. It's like the 1, 2, 3, 4, 5, 5th line down on this record here, that it begins to eventually, depart from that just straight line across, and then so of course it keeps going for over an hour that it's ringing, and then eventually the amplitude begins to drop, and it looks like waves, more like waves, I should say. And so that's from Tennessee. Here's one from Britain. So this would be one that probably only recorded the P wave, so it's far enough away from Japan that it wouldn't record the entire suite of different waves that would have affected areas closer to the Tohoku earthquake. But here you can see in Swindon, Britain, you can still see the needle swing off chart here, in fact. So massive earthquake at Tohoku here. Now, if that is the seismic record, okay, about how Earth rings from that energy that was transmitted from that rupture, the wave or the tsunami that developed from this is a column of water that would have been displaced, in this case, probably upward in this situation. It can be in either way. So you have to displace water, in other words, in order to have a tsunami. And so you get a column of water or you get a pit of water in which the water will rush in and then rebound outward from that. And this shows you the pathway of the tsunami across the entirety of the Pacific here. With a whole series, you can see the little triangles on here. That's where they actually measure the tsunami wave. And so they were able to do this at NOAA to record what was going on during the tsunami. And so this would take several hours in order for the tsunami wave to actually reach. It would probably take about 10 hours to reach Hawaii, maybe 8 to make it all the way to the west coast of South America. It would probably take close to 20 hours before it could make it. So they don't travel quite as fast as the ones that go through the Earth, obviously, because it's going through a liquid medium, right? So it doesn't transmit the energy quite as effectively. But even this earthquake, there was a tsunami at Santa Cruz. I have friends at Santa Cruz, and you could see actually video on YouTube for the effects of this tsunami, and it actually around Santa Cruz, California, of course, they have sailboats and things like that in the marina. And so the marina experienced a wave of about 1.5 or 2 feet high. And it took and pushed the water up into the marina district there. And then the water began to recede out of there. Of course, it was a massive volume of water. You take 2 feet instantly, almost instantly. You fill up the marina and then everything flows back outward. And so if you get on YouTube, you'll find videos of that as well. So if you just look up the 2011 tsunami Santa Cruz, you'll see a video of that. So that is pretty much, you can't really encapsulate the story of one major event like this with just talking for 15 minutes. In fact, it's going to affect some people for the rest of their lives, and some people lost their lives, and it affected their entire life, you could say. So we need to understand earthquakes in order to try to figure out, can we predict them? We're not very good at that. We're pretty good at predicting volcanic eruptions now, after we've had some of the major ones. We're not so good at predicting earthquakes, and so that's something that we're striving for, however. That's something that science may give us enough of a lead to be able to say, we might have an earthquake here, but the trouble is that spontaneous rupture occurs spontaneously. You cannot say it's going to happen on this date. You can more or less make a judgment and say there's a high probability that's going to happen in the next 10 years or 30 years or 20 years. And so we can lay probabilities on it, but we can't actually predict the exact time and date. And so when we look at all the earthquakes that have been recorded, now if you look at this, it says since 1898. Well, that's some of the first seismic stations that were ever in place at that time, and some of the first recorded events were at that time, so 1898. And then there's some really major earthquakes that happened. So 1906, we're going to talk about the San Francisco 1906 earthquake. So boom, these are where all the earthquakes are going off. And in fact, there's a nice illustration of this that shows you the magnitude and so forth. And that's another thing you'll find on YouTube. There's so many things out there these days, but it's very helpful. I'll try to provide links for those for this week, so you can actually see the animations that go along with these earthquakes, showing the magnitude and the depth very commonly. If we look at just the top 5 earthquakes, you see here that it started in 1952. There was a magnitude 9.0 in Kamchatka Peninsula. That's the peninsula in Russia that's a little bit above the Japanese islands. And so Tohoku is also a 9.0. And so that happened in 2011. So 1952, 2011, 2004, the Banda Aceh. Actually, I said 2005 earlier, but it's 2004. It was in 2003 that the earthquake occurred in Iran, and we'll talk about it in a little bit. And we'll also talk about Banda Aceh as well. So Banda Aceh was in Indonesia on the island of Sumatra, a 9.1. That's the one that generated the 2004 tsunami that killed 250,000 people around the Indian Ocean. So for Southern Alaska was 1964. They call that the Good Friday earthquake because it happened on Good Friday about this time of year. And it was a magnitude 9.2, massive earthquake there. And again, related to subduction of the Pacific plate underneath of the Alaska Peninsula there. And so huge. It was the Turnagain Arm earthquake of 1964. And then there was one in southern Chile in 1960. And the earthquake in Chile in 1960 was a 9.5. That's the largest recorded in this, since we've ever had recording devices. So 9.5, pretty much the limit, we think, on what you can get. Maybe a 9, you might get up to a 10, I suppose. In a long time frame, there's a potential for having a 10. But in 1960, that was a massive earthquake. It generated a tsunami that killed people in Hawaii. So 1960, a massive earthquake in Chile. Earthquakes were first described in 1177 BC. Okay, so the Chinese Chinese history records a lot of what is human history, and not only did they record that history from 1177 BC, I mean, you're talking way back there, right? Almost 3,000, over 3,000 years ago, and the Chinese were clever enough to even have a device that would serve as a seismometer. So because it was important, because the empire at that time spanned much of Asia, in fact, and so they wanted to know if there were distant earthquakes that were occurring, and so they built this device that you see over here on the right-hand side. It's a series of dragons that are surrounded, in fact, by frogs at the bottom there, and the dragons would have a ball in their mouth, and so if this vase were to shake, the ball would fall out of the dragon's mouth, and it would be caught by the frog down below here, and it would indicate that there was an earthquake, and they could actually tell what direction it came from that device, which is really, really clever, really clever. And so that is the first seismometer right there that the Chinese developed. Now, this one actually is after the 1177 event that was first recorded, but it's the first time it was ever recorded and kept in records that way. There were earthquakes in 580 BC that were noted by the ancient Greeks, and so the ancient Greeks also recorded earthquakes. And of course, the Hellenic plate in that area is very affected by earthquakes as well. You have the northern Anatolian fault that goes across northern Turkey, and then the Greece itself is affected by a lot of subduction. Of part of the Adriatic plate is being subducted underneath of Greece in that area. And even in the New World, in Peru, in 1471, there was a record of an earthquake in 1471. Now, this may strike you as being kind of unusual, right? Because when the Europeans first got to North America and, in the Caribbean and eventually to South America, that was 1492. And so this was before that event, before the spread of Europeans across into the New World here. Even the Incas were able to record these sort of events, and so the Incans had recorded this Peruvian earthquake in 1471. So these are things that affected all cultures across the entire world, and they still affect every culture across the entire world. And it behooves us. We live on one planet, so we have to be here to help one another. So also, if you're familiar with literature at all, there was a mention of the earthquake from Peru, and also from Lisbon, actually, too. There was a massive earthquake in 1755 in Portugal, and Voltaire wrote about that, actually. So he was living at that time, roughly, and would have experienced the destruction that happened in Lisbon in Portugal. And he made a speculation in the book Candide. Now, Candide is a kind of a comedy that Voltaire wrote, and he says, "In the best of all possible worlds, this is, and so he wrote about that. And there was a professor in there, and there was a traveling young person, the person who was there, the valet, if you will, that would help this young person as he was traveling across Spain." And he mentions, it's like, wow, this must be related to that 1471 earthquake in Peru. There must be a vein of sulfur that goes through of course, he was making fun of that whole concept. But today we recognize that these plates are everywhere on the outer surface of the world, and they are what generate these earthquakes. So if we go on, let's talk about some of the more deadly earthquakes. And so we're talking about, like, ones that have kill large numbers of people, and the largest that we know of didn't quite kill 1 million people, but there was one in the year 1556 AD, and it killed 830,000 people. You can see the location over here on the right-hand side. Oh, that's the 1976 earthquake, excuse me. 830,000 people. That was more in the middle part of China and up in the northern part of the middle part of China. And what happened in that earthquake is the people who lived in that region made caves, and they lived in these caves that were made out of a soft material. And so when the earth shook, that material collapsed. And so that material is still there and still being used for housing today, but they haven't experienced the sort of level of magnitude. Now, we don't have any record of how large it was, but usually the larger the magnitude, the more fatalities. And in some cases, it depends, of course, how heavily populated an area was. And so Shanxi in China was very heavily populated, even in the year 1556. The next one may surprise you. There was the Tangshan earthquake in China, and you can see the location over here on the right-hand side. It's very close to Dangzhou, where we have a sister campus, from Missouri State here. And so the Tangshan earthquake in 1976 killed 250,000 people. That was a very interesting time in Chinese history. It was after Mao had passed away, and there was what they called the Gang of Four, who were in charge of the political operations of China at that time. And so that news didn't get out. They didn't publish pictures. They didn't want to appear weak in any way. And so there was a magnitude 7.8 earthquake that occurred. Everybody kind of knew that happened around the world, but sadly, there was no international effort to try to help the Chinese at that time. And it was only after that the relations between many of the international large superpowers, really, so you have China, Russia, and United States as the main superpowers, let's say, and so, but there was no request for help, and I don't think any was delivered. But it was after this that President Nixon was able to then visit. Actually, it was before that Nixon visited in 1972. But relations had thawed somewhat by that time. There was a massive earthquake in 1138 in Aleppo in Syria. You may be familiar with Aleppo as one of the Syrian civil war locations. And Aleppo is an absolutely ancient city, and once held by the Crusaders. In fact, it was a Crusader city back in at about this time, in fact, so 1130s. And but the Syrian nation, lost 230,000 people at that time. It was an international city, really. And there's no record, of course, since it was so old, 1138. However, we did have seismometers in 1927. That's when the Xinjiang China earthquake occurred. There were 200,000 people killed in that one. So if you add all of these up, there's about 2 million people that were killed by earthquakes just in this list alone. These are the top 10 deadliest, right? And so 830,000 is a lot, 250,000 is a lot, and almost 250,000 in Aleppo, 200,000 in Xinjiang, and then Damshang, Iran is another 200,000. Gansu in China is an 8.6, that one. So these are all ones that are relatively recent. So 1920, 856 is an ancient one, of course, and then 893 and another one in Iran. What do they all have in common? You're probably wondering, is like, why are these all in either China or Syria or these other places that are far away? So we haven't experienced anything quite like that in the United States yet. But then again, the United States is a relatively young country. This is an area that was populated by Native Americans up until 500 years ago. And so here we have a record of ancient civilizations were affected all the way into the modern times. So Kanto, Japan's another one, 143,000 killed there. Turkmenistan, 1948, after World War II, 110,000 people killed there in a 7.3. And then Messina, Italy, in 1908, that was 100,000 people that died there as well. So let's look at some of these. And so in Tangshan, some of these we have cameras for because cameras were developed in the mid-1800s, so about 1840 was the earliest camera. And so people were able to take photographs. So in Tangshan, okay, that's the 1976 earthquake in eastern China. There's a monument in Tangshan that shows, people rescuing, young children and so forth. So that is a monument up here in the upper left. Kanto, Japan, 1923, you can see at the bottom down here, and it destroyed every building in that town practically, except for a handful over on the right-hand side over there. Many of these are double disasters, and I think Kanto was one of those. You can see some smoke rising up from this. People have to cook, people have to heat their houses, their dwellings, and so those are sources of flame. And when you have an earthquake and things fall down, you can ignite entire cities this way. And that's a very common story with earthquakes. And so earthquakes can generate massive fires. Conflagrations, we call them. Conflagrations are where fires occur that you just can't stop them. There's no way. There's no way to even get down a street in Kanto here, to put out a fire. And so people were killed by these sort of things. So in this case, in Messina, Italy, 1908 up here, again, we're talking about each one of these has killed at least 100,000 people. So Messina in Italy, it destroyed these buildings. We're going to talk a little bit about buildings and how you can survive an earthquake a little farther on here. Here's the one in China. This are some early photographs, 1927, of, this is a mission at that time in 1927. It's prior to the revolution, and this would have been, but after the Boxer Rebellion. So the Catholic Church was very had a presence in China at that time, and so these are photographs from various places where they had missions and so forth. And so that was in Jinning, China in 1927. Now, one of the things I get to tell you about, and I got to visit this one actually. This is the next on the list. This is in Port Royal, Jamaica. And I get to talk a little bit about pirates, I guess, too. So pirates are kind of fun for me. One of the famous pirates is my namesake. Actually, it was the same name. It was my father, John Evans. Was a pirate who frequented Jamaica here. And but in 1692, there was a massive earthquake in Port Royal in Jamaica. And so we're going to talk a little bit about this. So in great detail, actually. So this is kind of neat because everybody likes to talk about pirates. And so here you can see the old map of Port Royal. It doesn't look like that anymore. Half of the city was flooded by this earthquake. The bottom dropped out essentially on both sides of that peninsula. The peninsula is called the Palasoides, and it dropped down on the south side. It dropped down on the north side, and it left the kind of rocky core in the middle, high and dry. And so there was actually a fort. And so on here, down here at the lower left-hand side, you can see Fort Charles down there. So I have some photographs from Fort Charles when I visited last year, right as the pandemic was beginning to strike. And so that's where I was when this thing first began. So this is a map, a digital elevation map of Jamaica. Now, Jamaica's an interesting case. Jamaica sits right on top of the northern edge of the Caribbean plate. And so to the north of Jamaica is a small microplate called a Gonav microplate. And then north of that, of course, is the North American plate. And so that would include places in Cuba and so forth. So between Jamaica and Cuba is this sort of microplate. And what you see here is that Palazuites Peninsula that heads out into Kingston Harbour. So Kingston Harbour's on the north side of that, and then the Caribbean Sea is to the south of that. And so, but that's where the earthquake occurred. That's Port Royal in that circle here. Now, Port Royal is the famous site for where the British came into the Caribbean and to kind of wreak havoc, if you will. And so the British Crown offered what they call letters of marque at this time, which would allow British sailors to raid any foreign country, so mostly Spanish, because the Spanish were becoming very wealthy from South America. Actually, they were mining silver there, and that silver would be transported back to Spain through the Caribbean to Europe. And so the Brits were out there to try to pick off these Spanish vessels as they would return, these huge flotillas. And so it was Henry Morgan, in fact, who led two major raids on Spanish holdings. One of them was in Mexico, and the other one was in Panama, in Panama City, and the city of Panama. And so Henry Morgan was what they called a privateer. He had a letter of marque. And so eventually, when they saw that, well, they even, in fact, the Spanish at one time had the island of Jamaica and settlements on Jamaica, and then the British came in and invaded Jamaica and took Jamaica from the Spanish. And so he became one of the governors, in fact. And so as soon as they took the island of Jamaica, they said, okay, we're going to make privateering illegal from now on. From now on, you're going to be regarded as a pirate, and if we catch you, we're going to hang you. So you're going to get some of the themes from Pirates of the Caribbean in here as well, right? So it was actually Henry Morgan who was set up then as governor. Okay, so now, so Henry Morgan he was a famous pirate. He was from the country of Wales on the west of Britain, but he led those raids on Mexico, and he led the raid on Panama, and then he was placed as governor of Jamaica. And as governor, of course, he enforced the rules and lived in Port Royal. And so there are some other famous pirates. Actually, it's John Evans down here at the bottom. So that was the namesake for my father, in fact. I don't know if my father was named after the pirate, but is the same name, of course. And so it wasn't just Brits. You know, although John Evans is Welsh and Henry Morgan was Welsh and Edward Teach, Blackbeard was Welsh. Many of the famous so-called English pirates were actually Welsh. Okay, Wales is a small maritime country on the west side of Britain. But it wasn't just men. It wasn't just the Welsh. It wasn't just the British. There were French pirates as well. There were Spanish pirates also, because anytime you could go out and try to, make your wealth, essentially. I sometimes think that that's the same thing that people are doing today with like SpaceX and things like that. There's a certain pirate aspect to this whole thing. But anyway, it wasn't just men even, right? So there's a couple of famous women pirates as well. And so you can see, what's her name? Bonnie, I can't remember what her last name is, but then also at the right-hand side over here, that's Jack Rackham. And so Jack Rackham was hanged, in fact, and his body was kept out at Rackham Key, just off of Port Royal here. So that's a little bit of the pirate history anyway. So here's a photograph that shows you what it looks like. This is Fort Charles. That's the same fort where he was hung. Okay, so that is the part of Port Royal that didn't subside below the seas like everything else did in that sort of event that led the earthquake and the tsunami, the settling that led to the flooding of Port Royal. There's our tour guide over here on the right-hand side. So that is the opening or the entrance to Fort Charles there. Interesting history there as well. Many of you recall when we were talking about what is science, and actually we were talking about heliocentrism as opposed to geocentrism, and I a little bit about this revolution that was going on in science at that time. I talked about Cromwell, Oliver Cromwell. So Oliver Cromwell had overthrown the British crown. And when Oliver Cromwell was when they restored the kingdom back to Britain, it was King Charles, and that's who this fort was named for. After it was once named I think it was Fort Cromwell or something like that, but it was named for the insurrection that led to the overthrow of the British monarchy. And when the British monarchy was restored, it became Fort Charles. It's an absolutely fascinating place to visit. That is the jail over here on the left-hand side, and so it's got 2 levels to the whole area, and so they can drain the sea out of the bottom level essentially, and so the houses were built high enough to withstand hurricanes, things like that. But that's actually the jail in the lower part on the left-hand side here, and that's on the upper level up here where this huge tree is growing out of the fill material there. Beautiful place to visit, very historic sort of port. In 1692, that fort was still there. It had been around for almost 100 years already at that point. And so that earthquake affected this area right here. So that's kind of cool. This is so that's the place where they keep the gunpowder, the magazine they call it. Here's my colleague Bob Pavlovsky, who's at the top of this lookout up here, and so he's in the eastern part of the fort here. If you went downtown in Port Royal, you can actually see some of the village here, but that was all built up after the earthquake. The main part of town was destroyed in 1692 by this earthquake. Okay, on the lower right-hand side, the far right here, is one of the new powder magazines, where they kept some of the goods and so forth. It was tilted in a 1908 earthquake here, I think it was 1908. Anyway, the whole thing was like it shifted, right? So it began to settle on one side during an earthquake. And so you can go into structures like this and try to walk around if you can in them. But if you go back to that time period, it was even published in some of the local papers, and not the local ones, but in Britain. And it shows you an illustration of here what it would have looked like in Kingston Harbour. On the right-hand side, it shows you the Palacewides, and at the very tip of that, in fact, is where Port Royal is located on the left-hand side of that photo here. And so you can also see these ancient woodcuts, these old woodcuts. They're over 400 years old now, and it shows you some of the destruction here. And so people were actually swallowed by fissures that opened up in the land, and then they would close back up. The dogs were running around, and so you can see people falling into these cracks. And so some of this is from Port Royal. You can see the water had moved in here. There was destruction also on the Kingston side, but Kingston was less popular at that time. This illustration shows you what it was like where there's rock underneath the Palacewides. It's mostly coral rock for the most part. And there was unconsolidated material on either side. So the fort was built on the rock, and most of the town was built on the sand, and the sand subsided. And many of those houses are still underwater today. As it turns out, so even Henry Morgan's body was washed out of the cemetery where he was buried after he had passed away sometime before that earthquake. And so a really sort of an amazing sort of story here. It's how even the most wicked city on earth, which was destroyed by an earthquake, you can read into that however you want, but a lot of people view that as God's destruction of this landscape. But there are stories about people who survived that, truly wicked people who were pirates and people that they associated with, and some of them survived. And so they were like, 3 different times that one a victim of that impact. He almost died 3 times, I think, from that earthquake. 1907. That's the year that the Kingston earthquake occurred. That's when that building was tilted in 1907. And it shows you the destruction that happened in Kingston. So that's just across Kingston Harbour from Port Royal there. Now, why did that happen? Well, as it turns out, like I said before, the northern edge of the Caribbean plate runs right through the middle of this area, really. It doesn't go through Palisades directly, but it comes all the way from Haiti. Now, Haiti, you probably remember the 2010 earthquake in Haiti. That is called the Enriquillo Plantain Garden Fault, and it runs all across through the Dominican Republic, through Haiti, it runs along the peninsula in southern Haiti, and then it runs across what they call this Mona Channel here, and it heads all the way into the island, and then it kind of deviates and splits apart into three different sort of segments here. But that Enriquillo Plantain Garden Fault was the one responsible for the earthquakes in Kingston and also in Port Royal. And so it was a plate boundary. So you can see on here the geology of this. And so the faults are actually marked with the bold black line that cuts through here. So Jamaica, 150 miles across, 50 miles up and down. 3 million people live there. And it's very mountainous. It's a wonderful place. I've gotten to visit there like 6 times, maybe. Incredible place to enjoy the hospitality and the scenery and the people who live there. So, along the same theme here in the Caribbean, if we take the Enriquillo Plantain Garden Fault to the east, you can actually see where it caused the earthquake near Port-au-Prince in Italy, in Haiti, and 316,000 people lost their lives in this. Now, why? It is one of the deadliest earthquakes, and it should have been on the list previously, but this one is probably burned into your memory, and so many of you may have actually gone to Haiti, as part of some sort of mission to help provide aid for the Haitian people. Haiti is the poorest country on earth. When this earthquake occurred, it was the 12th of January. This is before the Tohoku Earthquake, a magnitude 7, so it's not even as large, but at the same time there were more fatalities. And as it turns out, the thing that kills more people than anything are structures. When structures collapse, they kill people. And so that's usually, the earthquake itself, the shaking, unless you're caught in one of those fissures, and that's only going to be a handful of people that may get caught in fissures and that open up or maybe killed by a landslide, from an earthquake. But most people, in fact, are killed by the buildings. And so it's almost a self-inflicted wound when we don't build buildings that are able to withstand earthquakes. And so the ones that are the best able to withstand earthquakes tend to be frame structures, ones that are made out of wood, but because they rot, they mildew and things like that, people build their houses out of stone, masonry, or they build it out of concrete, which is another masonry product. And so here is a photograph of Port-au-Prince. This is after the earthquake in 2010, so this is a Google Earth image, and so they flew satellites over it to see what was going on there, of course, and we're going to zoom in on this. And so here you can see downtown area of Port-au-Prince here, and if you zoom in farther, you can even see some of the people who are living along the streets here because they don't trust the buildings to not fall down from some of the aftershocks that hit after the main earthquake. And so what you see here are a lot of blue tarps. The blue tarps are ubiquitous, right? And so blue tarps indicate some sort of disaster or something that's an aftermath of disaster practically. And so you can see where people are living in the streets then after this earthquake. There's no safe place to live. And it was a difficult time. It was difficult for people to obtain fresh water, fresh drinking water, and to sustain themselves with food and so forth. So there were long lines of people that were in dire need of help. And so the international community was able to come together to try to help as best they could. And of course, you have to evaluate how effective were you? What are the infrastructure changes that need to be made in order to help people survive situations like this? This is the seat of government. Actually, it's the Prime Minister's house. I think it's the palace in Port-au-Prince here, and it was pretty much destroyed by this earthquake. You can see how the top part here had collapsed into the lower part here. Here's a church in Port-au-Prince here. You can see a doctor administering aid to a young man here, a young child here, over on the upper right-hand side. It was a humanitarian disaster as well as an earthquake disaster. I think we learned a lot from this, and people are still visiting Haiti in order to try to help the Haitian people. It's a hard country to try to help people. After the earthquake, a lot of people were loaded onto ferries like this to take them to safer places to live, where they could actually, get them off of the streets so you could even drive a vehicle down the streets. Everybody was living in the streets just to be able to deliver help and to help facilitate getting people to hospitals and things like that. And so here they are taking some of the survivors to camps elsewhere in the country to be able to make ends meet here. And so, wow, what a situation. Well, I'm gonna leave it right here for now, and this is gonna be kind of the end of this week's lecture series for us, anyway. And but it's just to get you first of all acquainted with these are natural disasters, and we live in a perilous planet. We live in a place that can kill us, and it sometimes does. And so we're going to stop with Haiti here and move on to other examples of that. And so that will be for the beginning of next week. And so we'll talk a little bit more about earthquake disasters and some of the things that happen in these disasters. But anyway, you can look forward to this part being on the quiz. And so I may ask you questions about what is an epicenter, what is a focus, what kind of waves do we get from this as well. So that'll be in the quiz coming up on Friday. So this will be the end. So the plate tectonics and the Earth's interior will be the first part of the quiz. And this will be the end of the quiz here with the first part of earthquake disasters. And that'll start next week then with earthquake disasters and then earthquake processes. Anyway, thanks for your attention. And welcome back from spring break. Everybody did so good on the exam. I'm very happy with that. And so you need to keep it up. It's like you're doing a good job in here. And I'm sorry this is the way we have to do things, but it's just what we have. I'll talk to you soon. Thanks. Bye.